Start recording?
Yeah.
Okay. Okay. So do you see my screen, girls? Summary of notes for the light topic?
Yeah, we do.
You do? Okay, that's good. Okay. So good morning again. Now what I'm intending to do this week is that we will revise light and waves topic. And I have already set 3 past papers, 2016, 17, and 18, and in the Google Classroom with the answer, so you can go through those one. So I thought that in today's kind of session, I will just briefly go over the main things that you need to actually go and revise. Okay, is that all right? Do you hear me?
Yeah.
Okay. Okay. So first thing is, first concept is about reflection in concave mirrors and convex mirror. Okay, so this is a concave mirror and that's the convex mirror, and generally parallel rays, they bend inwards, and this point is called the focal point. And the convex mirror, reflected rays go outwards. So this one over here, where the reflected rays appears to be coming from, is a virtual focal point. It's not a real focal point, so it's a virtual focal point, and this focal length is negative, whereas for a concave mirror it's positive. Okay, now you will be asked to draw the ray diagrams, and so if this is a concave mirror, and that's just a mirror line, and say for example this is the object, then normally we've been using 2 rays. So the first ray is the one which is going parallel. It will be reflected to the focal point. Second one that we've been doing is this one. It goes towards the middle of the mirror and it reflects at an equal angle. You can draw the third ray if you like. And third ray is the one which is passing to the focal point and it becomes parallel. And somewhere over here, all the 3 rays meet, but you need only 2, whatever you like, you can draw those one. So because real rays are meeting here and making an image, so it's a real image. And at this position, it is smaller, but it could be enlarged, and it's upside down. Now, for a convex mirror, so that's a convex mirror. Again, the 3 rays, parallel ray going outwards. The second ray, which is going towards the middle, reflects at an equal angle. And now, because rays don't go behind a convex mirror, it only appears that these rays are coming from the behind the mirror, from this virtual focal point. So if we extend these rays over here and we extend these rays over here, this is where they meet. Now, sometimes there's the third ray that I've drawn here with 3 arrows, a ray which is going towards the focal point, it becomes parallel. We have not been using this ray, but in 2016 exam, one of the ray is this one where you have to complete the diagram. So they've given you this ray and that ray, so you have to complete it. So you can come back and look over here. So this ray, which is going towards from the head of the object, is going towards the focal point, which is a virtual focal point. But from here, it doesn't go back, but it becomes parallel. So this type of image, where all the rays appear to be meeting, this is a virtual image. So the difference between real and virtual image is that this image can be seen. So if you have your eyes over here, you can see the image, but it cannot be projected on a paper or something you can't see on a paper. So this is because it's made up of virtual rays. Rays don't go behind the mirror. So that's the difference between a real image and a virtual image. Is everyone following so far? Do you hear me?
Yeah.
Okay, good. Now, it doesn't matter whether it's a concave mirror or convex mirror. These are the formulas that you use. DO is the distance of the object from the mirror. DI is the distance of the image from the mirror. In this case, it will be negative because it is behind the mirror. focal length is positive for a concave mirror, but for this mirror, which is a convex, it will be negative. Magnification is distance of the image over the distance of the object. So if you know these one, you can calculate magnification, and these were height of the image over height of the object. So from here, you can, if you're given the height of the object, you can calculate height of the image. Now, this is just a summary of images formed by concave and convex mirror. So concave mirror, this one is just giving you the rays, but so this is just a brief summary. So, and if you go back in your own notes, you will find that at different position, images are formed. There will be different type of image. So going back here, a concave mirror makes two type of images. If object is standing from here to there, it will be making a real image. It will be upside down, but it could be enlarged or it could be smaller. But when the object stands between the mirror and the focal point somewhere over here, then it makes an enlarged virtual image. So, you know, like when you stand close to a makeup mirror or something, it gives you an enlarged image because you're standing within the focal point and the mirror over here. So this one makes two type of images, concave mirror, but convex mirror only makes one kind of image. Okay, now let's move on to the next part. Okay, now what do we mean by refraction of light? So when light goes from one medium into another one, so for example, this is air and this is water, and water is the denser medium, so ray will bend towards the normal. Or in other words, angle of refraction is smaller than that one. And so we will be using these formulas. These formulas will be given, but N1 is the refractive index of this medium. For air, it is 1. N2 is the refractive index of this medium, which will be, if it's water, it's 1.3, or for glass, it will be 1.5. And these are the angle in the first medium, angle in the second medium. And then this formula is wavelength in this medium and wavelength in that medium. So these formulas are true not only for light, but also for waves. Okay, sometimes they might give you 3 mediums. So light goes from air into water and then into glass. Then you can write down this formula as N1 sine theta 1 equals N2 sine theta 2 equals N3 sine theta 3. So if you're given the angle in this medium, not in this one, but the third medium, so you can equate this part with the third part and do your calculations. And that's one of the questions in 2016 exam. Okay, now what do we mean by critical angle and total internal reflection? So say, for example, this is the denser medium like water, and this is lighter medium air. So for smaller angles, there will be some reflection and there will be some refraction. But what happens is at a particular angle, the light will go along here. So for this, the red ray, if we shine the ray from here, it will go along here. So that means angle of refraction is becoming 90 degrees. And if the angle of incidence is larger than that, then total internal reflection will take place. So ray number 3 does not come out into this medium. It goes back at an equal angle. But for internal reflection to happen, there are 2 conditions. One is that angle of incidence has to be larger than the critical angle. This is the critical angle for which angle of refraction is 90 degrees. Second condition is that light must be going from a denser to a lighter medium, not from a lighter, because if light goes from here, then it will be bending this way. So this angle will always be smaller. So there will be no critical angle or no total internal reflection if light goes from a lighter to a denser medium. It only happens when it goes from a denser towards a lighter medium. So that's the third thing. And now lenses. So lenses let the light go through, whereas mirrors reflect them backwards. So a convex lens converges the light rays towards the focal point, and a concave lens, so light rays are coming from here, so these are the incident rays, and they go outwards. And these dotted lines show that it only appears as if they're coming from here. So this is the virtual focal point. And this from here to there is the focal length, which is negative for a concave lens and positive for a convex lens. Again, you will be asked to draw ray diagrams for lenses. Now, formulas are still the same as we used for the mirrors, okay? But you have to remember that focal length is positive for a concave lens and negative for a convex lens. Now, these are just some ray diagrams. So if you have a convex lens, it can make different types of images depending on where the object is. So let's look at the first one. Object is standing quite far. So that's the focal point on both sides, because light can come through here and go there, or it can come through here and go there. Now, so first ray goes straight and goes to the focal point. Second ray, which is going towards the middle, keeps going straight, and they meet here. So that's where the image is. Okay. So again, similar one, but as the object moves closer to the lens, image is still real, but it is becoming enlarged and it's upside down. If object stands at the focal point, then no image is seen because the rays become parallel. It is a similar thing for mirrors. If object stands at the focal point, no image is seen because rays become parallel. Over here, if object is standing, so this is the object, the little one, between the focal point and the lens, then it makes a virtual image. Again, rule is same. First ray going towards the focal point, second ray passing straight, but they are diverging. So you need to extend them backwards with virtual rays. So that's where the image is. So convex lens makes real image and a virtual image, as shown by these one, whereas the concave lens only makes one kind of image. Okay, so that is ray going over here, goes outwards, appears coming from the focal point. The one which is going straight keeps going straight, and image is formed somewhere over here. You can look at these one in your own notes, which I'm just giving you a little kind of a summary. Okay. Now these are some detail. I don't have that much time to go through these one. So this is like a summary of notes on light. Is everyone following so far?
Yeah.
Okay. Now I will just briefly show you some notes on the waves topics. Okay. What do you need to learn in waves topic? So first of all, this is pulse. These are pulses. So reflection of pulses. So n could be a fixed n, or it could be a free n like that. So if a pulse is coming towards a fixed n, it will reflect back. Okay, so it will be inverted. A crest will become a trough. Whereas if it reflects from a free n, then crest stays crest. So this is called reflection of pulses or 1D waves. Remember, pulse is a small part of a wave. A complete wave will be a crest and a trough, but rule is still the same. Now, have a look over here. Now, this is the refraction of pulses. So, a pulse is moving from a less dense to more dense. Denser medium means it goes slower in this medium, and that's the junction. So when this pulse goes into this one, part of it is refracted, and or we call it transmitted, and part of it comes back. So because energy is dividing into 2 bits, therefore amplitude gets smaller for both of these one. So A refracted pulse wavelength will be smaller because its speed becomes slower. This one, wavelength is smaller, but only difference is that amplitude will be smaller as compared to the incident one. So it divides into 2 bits. Now, if it is going from a denser to a faster medium, so this is faster medium, and pulse is traveling this way. Again, it divides into 2 bits. So this one, because it's becoming faster, and why does it become faster? Because the wavelength gets longer. And for the reflected pulse, it stays the same length, but the amplitude gets smaller because energy is dividing into 2 bits. Now, let's say a reflection of 2D waves. So that's the incident wave, that's the reflected wave. Angle of incidence is equal to angle of reflection. Speed remains the same. And now these lines over here, these are called wavefronts. So the wavelength of the reflected wave is same as the wavelength of the incident wave. Okay, now we look at the refraction of 2D waves. Now, if you look over here, now this is the denser medium, this is the lighter medium. So wave is going at 90 degrees angle to the boundary. So if it goes at 90 degrees angle to the boundary, it doesn't change direction. It will keep going straight. But because, this one is a deep water, and deep water is faster. So this one is a faster medium, and the lighter one is the slower medium because this is shallow water. So only thing that happens is that wavelength gets smaller because it's getting slower, so the waves bunch up. Frequency remains same. So frequency in this medium and that medium is same. Second one is showing that wave is traveling from a faster medium into a slower medium. So not only the wavelength is getting smaller, it is bending towards the normal. So this was the normal over here, and so it is, instead of going straight, it's bending towards the normal. This one over here is, again, it's going from a faster to a shallow medium, so the wavelength is getting shorter and is bending towards the normal. If we look in a little bit detail, again, this is deep water means faster medium, shallow water means slower medium. So this wave, so that's the direction of the wave travel. That's the wavelength from here to there. That's the wavelength of the refracted one. So it's becoming smaller. And if you look at the direction, instead of going, this is the normal, instead of going straight, it actually, this red line, this dotted line is the normal. So instead of keep going straight, it bends towards the normal. So what's happening is wavelength is getting smaller because speed is getting slower and it's bending towards the normal or bending towards the boundary. So you need to be able to draw these patterns. And this one is like opposite. It's going from a shallow water into deep one. So this is a faster medium. So wavelength of this wave is getting longer or bigger because it's speeding up. And instead of going straight over here, that's the normal, is moving away from the normal. Okay. Now, formulas are similar to what we had for the light ones, N1V1, N2V2, N1 that one. But this is the basic formula for the waves. V equals F lambda, F is the frequency, lambda is the wavelength. So remember, in all of these, one frequency in this medium and that medium remains same. Okay. And this one, N1V1, N2V2, these are the two mediums. So like, for example, this was the one medium and that was the second medium. Another concept that we had to learn in this waves topic is diffraction. So if you first of all look at these two waves, so wavelength of this one and that one is same. So waves are going in this direction, and this is the gap. So when they pass through the gap, they become straight waves, they become circular, they bend. So bending of wave is called diffraction. Here, they're bending less, but when gap is smaller, they diffract more. Okay. So here, what we are saying is that greater diffraction if gap is smaller. Second thing that diffraction depend on is, like, if we compare this with that, because this gap is same as that one, but here waves are diffracting more because here wavelength is longer. So the waves which have got longer wavelength diffract more. So for example, sound waves, they diffract more as compared to the light waves. So you can hear someone from next door or from the corridor, but you may not be able to see the person because light waves don't diffract as much as the sound waves. Sound waves have got a longer wavelength, or in kind of light, red light has got longer wavelength, so it diffracts more than the blue light, which has got shorter wavelength. Last thing in the waves topic is interference pattern. So when it shows these are the two sources, light waves, these are like two gaps or two sources, they're producing waves and they interfere with one another. So these ones over here, so at some places they will constructively interfere, at some places they will destructively interfere. So the red lines is where the waves from these two sources, they constructively interfere. So this is called an antinodal line. And path difference is 0. So that means two waves are traveling the same distance. So here you will see bigger waves with bigger amplitude. This is another antinodal line where constructive interference happens. This is another, similar on that side. Blue lines are where the two waves from these two sources, they destructively interfere. That means crestwise on a trough, and they cancel each other. So if this was a water, these were two water waves or two sources producing water waves, then there will be calm water here, where it will be choppy water here because constructive interference. Now this one just tells you what do we mean by constructive interference and destructive interference. So when two waves, when they are in phase, crest lies on a crest, it gives you bigger wave, and crest lies on a trough gives you, they cancel each other's effect. So in interference, main thing is finding the path difference. So path difference is 0 wavelength, 1 wavelength, 2 wavelengths here, but constructive interference, constructive, so bigger amplitude. If these were light waves, what you will see over here is a bright light, bright light, bright light, but there will be dark or no light here, no light where these are called nodal lines. The blue ones are nodal lines and these red ones are antinodal lines. So guys, that is a brief summary of the whole topic. So you need to revise all your notes. And is everyone all right so far? Can I stop sharing the screen?
Yeah.
Okay, so. Okay, I got to see all of you here. I haven't said hello to everyone, but basically, so that was just giving you a summary or kind of overview of all the things that you need to actually have, need to go through. So in your own time, if you could revise all your notes for light topic and waves topic, and now different people will do it kind of differently. Some will like to revise all the notes first and then come and do the paper. Some would like to actually do the question paper for the exam and then go back and refer to the notes. So it's up to you, whatever method suits you. But for this week, there will be 3 exams, 2016, 17, and 18 that you have to do. And then you will, 2018, you have to submit it as an assignment. So you will need to print it, write down your answers, mark it, grade it, and submit it. So hopefully, does that sound all right, girls? Three exam paper is all right? Like generally you will be asked, in an exam situation, you will be asked to spend 1 hour doing each paper, 1 mechanics, 1 light paper and light and waves paper, and 1 electricity. So now you've got like 4 lessons, and so for each and every lesson, roughly we are supposed to be spending 1 hour in classroom and maybe half an hour's homework. So that gives you roughly, say, 6 hours. So I'm hoping that you should be able to complete those 3 exam papers and then submit. It will be last one, 2018 is due on Friday. And one more thing, girls, if you haven't submitted your, I think other than 1 or 2, most of you have submitted your electromagnetism assignment last week, but some of you still need to work on your mechanics exam, which was 2017 exam due last, I think it was due on Friday. So try to do that one also. You might think that I'm just giving you too much to do, but exams are quite close. So if you work hard now during this week and next week, so then you will have a little bit more relaxed time in the holidays. So this is week 9, week 10. So we will be complete. We are doing light and waves this week. Next week, I'm planning to do electricity, revised electricity topic. And then it will be holidays. So holidays, you wouldn't have got that much pressure to do that much revisions. If you are working harder for last week, this week, and next week, then hopefully we will be in level 2 during the holidays and you can enjoy your time. How does that sound? All right?
Good. Yeah.
Okay. Yeah.
Good.
Any questions, guys? For notes or anything, general question?
No.
No? All good?
Yes.
Okay. So thank you again for joining in, and I hope this helps. If you haven't got your notes or anything, go back to Google Classroom and you will find all those notes in Google Classroom. So all what I have talked about today, they're all in Google Classroom. I will put these ones too, the summary that I have put, but it doesn't have all the things. Each and every lesson's notes might have a little bit more things in there. So just go through those ones. So if there are no more questions, then I will end the meeting. And thank you, Neela, for recording.